In problem 1.2, we've already answered questions A, B, and C in a previous lesson, and so now we're going to focus on question D. We're given two hubcaps, two images that are really sort of look like a hubcap might look on a car, and we're asked to mark the center of rotation and find all the turns less than 360 degrees that will rotate it to a position in which it looks the same as it's pictured. So we're really looking for the angle of rotation and the center of rotation. So we're going to start with hubcap number 1. Hopefully you see the center of rotation is in the very center, in the middle. And that if I draw a line from the center out through one of the spokes of the hubcap, and then find another spoke that's so about there. So right there, that angle is the angle of rotation. And really, if you think about it, if I rotate it that much, and I can continue to do that, if I take, and I'm going to have, looks like 5, as you can see the 5 different parts of this. The 5 angles that I can rotate it at. Those are the 5 different directions that I can go. And now I'm going to use my angle ruler first here and see if I can find that angle. So I'm going to set that 0, and it looks like if I get my angle ruler set on here and read the angle that I just took off of it, looks like it's around 70 degrees, which is kind of, it's not exact. And so rather than using the angle ruler in this case, I know that all the way around is 360 degrees. And there's 5 angles. So if I take 360 and divide it by 5, then I'm going to get a little more exact. It looks like it's 72 degrees. So each of those is 72 degrees. And so all the different angles I can rotate this at are factors of 72. So if I think about one turn would be 72 degrees. If I go 2 turns, so I can go 72, I can go 144 degrees. That would be my second turn. And I can go then 216 is 3 turns, 72 times 3. And then the next turn be 288. And then, of course, all the way back around is 360 degrees. If I make each of those turns, 72, 144, 216, 288, and 360, those will all rotate this image back around. If I spin it that number of degrees, I'll see the same image again, over again. Now, the second part of this is to tell whether it has reflection symmetry. So, and we did reflection symmetry in problem 1.1, and so the question is, could I take a mirror here and set it in the middle of this and get this image back the way it originally was? And it looks like I can set the mirror right there, and I get the original image. So that not only does this image have rotation symmetry, but it looks like it has a bunch of lines of reflection symmetry. So there, again, if I take my mirror, reflects on itself. So it looks like all of these lines I drew of rotation symmetry are also lines of reflection symmetry. So I'm going to put some additional lines in here. I'm going to use a different color so it shows up differently. So we extend this line through here, and that becomes a line of reflection symmetry. So all of these lines now also create lines of reflection. So the image reflects over onto itself. So you can see it actually has 5 lines of reflection symmetry. So I can either rotate this image to get it to look like it was, or I can reflect it across one of its parts. So those are all now lines of reflection symmetry, as well as rotation symmetry. So that was for hubcap number 1. Now let's see what we can find for hubcap number 2. Hubcap number 2, center of rotation in the center. And now the question is, where would I draw lines of rotation? I think I'm going to go with a line kind of halfway between each of these shapes here and see what that gives me. So if I like that right there, trying to shoot for about halfway between each of the little shapes on the outside edge of the hubcap. And it looks like, since there's 3 of them, if I go something like that, this last one might be off a little bit, but again I have 3 rotations, looks like, and so 360 degrees divided by the 3 is 120 degrees for each of these rotations. So I have 120 degrees is my angle of rotation, and then my center of rotation, of course, is the middle of the hubcap. Now the question with this one is, does it have reflection symmetry? So can I find a place where I can reflect this image over onto itself? And so you can see that, not quite. See that image, the right image shape here, when I reflect, doesn't reappear. So that doesn't give me a line of reflection symmetry. In fact, the image at the top, you can see, changes its shape completely. So maybe if I go somewhere else, maybe if I go in between. So let me rotate this around the shape and see if we can find a spot where we get the original image back. And it doesn't look like I can do that. So it looks like hubcap number 2 only has rotation symmetry. It does not have reflection symmetry. So in this case, we have no reflection symmetry. We only have rotation symmetry, 120 degree rotation symmetry. And the different angles that I can rotate it and still get that image back are 120 degrees, 240 degrees, and 360 degrees. Those are my 3 rotation angles that I can rotate it and get it back to what it originally looked like. And so those are the ways you can rotate or reflect particular images in order to get them back to their original. All of this symmetry is about being able to see an image in its original form, do something to it, either rotate it or fold it over onto itself, and then still have the original image that you started with. So for problems E, F, and G, then you're going to be challenged to make some drawings of your own that use these types of symmetry to do that. So I'll leave that part to you for now.